Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Technically Explained. In this video, we are going to design a microstrip patch antenna for GSM application using the Cst Microwave Studio. As I told you before that we have GSM 2G and GSM 2.5G. The frequency of GSM 2G is 900 MHz and the frequency of GSM 2.5G is 1800 MHz. So in this video we are going to design a microstrip patch antenna in the 1800 MHz band. And these are the dimensions of the antenna. The width and length of the substrate and ground is 80 mm. The height of the substrate is 1.6 mm. The length of the patch is 38.4 mm. Width of patch is 49.3 mm. Length of feed line is 20.8 mm. So it does not matter uh, in deciding the resonant frequency or the performance of antenna, but still the length of feed line is 20.8 mm. The width of feed line is 3.137 mm and the thickness of ground or patch is 0.035 mm. So these are my dimensions of my these are the dimensions of my microstrip patch antenna. So let me go to the Cst Microwave Studio and let me start designing. So I'm going to click on new template and then I'm going to click on microwave and radio and optical, and in the sub region I'm going to click on antennas, click on next, select planar, click next, select time domain, next. In the frequency we are going to change the unit to the megahertz, and then I'm going to click on next. To give it the frequency range, let us select the frequency range from 400 MHz to say 2400 MHz, and the far field should be defined at 1800 MHz. I'm going to click next and I'm good to go. So let us start the GST environment. Again, the first thing I need to do is to define the parameters. So let us start defining the parameters. I have the width of substrate, which is 80, and then I have the length of substrate, which is also 80. Height or thickness of substrate denoted by H is 1.6 mm because we are using the FR4 substrate. And then we have the width of page, which was here, it was the width of page is 49.3 mm. The width of page is 49.3 mm and the length, okay, and define it as L. Let me define it with small w. The length of page again we have here, which is 38.4. This is 38.4. Then we have the height of ground, which is 0.035. And the other parameters are the length of feed line, which is 20.8, and the width of feed line, which is 3.137. So now we have defined the parameters. Now I will start designing. So to start designing, I'm going to click on modeling and select the break. First I need to define the ground, so let me name it as ground, and then again the width of the ground is equal to the width of substrate. So I'm going to give it values minus ws divided by 2 to ws divided by 2. Similarly, on y-axis we have the length, which is minus ls divided by 2 to ls divided by 2. So the total length of substrate is ls, substrate or ground is ls, and the total width of substrate or ground is ws. So I'm going to define it as minus g, so that it's below the z-axis, and then I'm going to load the material from the material library, and I'm going to select copper. I'm going to click load. This material will be loaded. You can see in the preview minus ls. So here we go, we are good to go. I'm going to press OK. So now my ground is designed. The next step is to design a substrate. Again, substrate dimensions are The length and width of the substrate are same as the ground. The only difference is in the height of the substrate. So we have to define the width here, then we have to define the length over here, and then we have to give dimensions of height of substrate, because uh, the ground ended at 0, so we can have 0 to h as our substrate. So I'm going to search for FR4. We have FR4 here. This is its tan delta, and this is this epsilon. So I'm going to click on load. You can see in the preview, this is ws by 2. Why? Because the width of substrate has been defined by ws, not w. We can see in the preview we are good enough to go. We can click on OK. Now the substrate and the ground has been designed. Next is to design the page. So the page width was w, so I can give it dimensions of w by 2 along the x-axis. On in the y-axis we are going to give it. Now the page should be on the top of substrate. It should start from height h, and the height of this page should be h plus z. It should be made from copper. We can see in the preview we are good enough to go. So let me have a front view of this. Now what I want to do is to design a feed line. Again, to design a feed line, I can know the width of the feed line from the macros here. From the macros, I'm going to click on calculate and click analytical line impedance. From here, I'm going to scroll down and click on thin microstrip. When I click on thin microstrip, I can now know the width of the feed line, which is denoted by W here. So my height of substrate was 1.6. My relative permittivity is 4.3, and my frequency is 1800 megahertz. So I'm going to click on calculate here. So there we go. We need to give it a height of 3.137 by trial and hit and trial method. So when you give it a value of 3.137, the impedance of this width of the feed line will be 50 ohm, which is our requirement because our connectors are of 50 ohm impedance. So that's why the width of the feed line is chosen to be 3.137. You can have a look here. Let me exit it. If you can have a look in the parameter, this is selected as 3.137. So now we are going to select the design the feed line. So what I am going to do is that I am going to pick the middle point. So in the modeling, I am going to pick points, pick middle point, and click over here. Let me readjust, and then I am going to align the local coordinate system at this point. So now the local coordinate system are aligned on this point, and now I am going to define the feed line. So I am going to name it as feed line. On the u-axis we have the width of the feed line because u-axis is now the x-axis. Fine. So this is minus wf divided by 2 and wf divided by 2. So the total width of this feed line is wf. And the length of the feed line is, it should start from here and extend till LF. The LF has been calculated based on these dimensions. Because the total length of this page is around 38.4, so the length of the feed line, and this page is at the center, so the length of the feed line should be 20.8, which is calculated here is 20.8. Again, because now I am on the top of the substrate, so I don't need to give it a substrate height, I need to give it a height of G, which is equal to the height of ground or the height of page. So we are good enough to go. Then I am going to get rid of this local coordinate system. As you can have a look, we have the feed line and the substrate. Now what I am going to do is that I am going to add the feed line and the substrate. So I am going to click on feed line, then I am going to click on boolean and add it with page, and now this has been added. Now our antenna is ready. We have the substrate, the feed line, and the ground underneath. Now what I am going to do is to define the ports. So I am going to zoom it over here. Let me just drag it. it down and zoom it more so that it's more clear to us. So I'm going to pick this face by clicking on pick and pick face. I'm going to pick this face, and then in the simulation I'm going to go to the waveguide port and I'm going to define my waveguide port. It should be 3 star the width of the feed line, again 3 star width of the feed line extended, 6 feed line in both direction. This should be h plus g and this should be 4 times the height of the substrate. So we are good to go. I'm going to press OK. So now this is my antenna. You can see on the front view. Now this is my antenna. The port has been added. Now we are going to go to the simulation. So I'm going to click on setup solver and I'm going to start the simulation. So the simulation has been started. This is going to take few minutes. So I'm going to pause this video here and then restart again. So the simulation is complete. So now we will check the results. First of all, in the 1D results, I am going to check the S parameters. So these are my S parameters, and as you can have a look, the antenna is resonating at 1800 megahertz. So this antenna can be a perfect candidate for the GSM application, for the GSM mobile communication. And to know the bandwidth, again I can right click and I can click on show axis markers, or I don't want to show the axis marker, I can click on show curve marker. So if you can have a look, I have already selected the curve markers, and at one curve I have the 1784.5 and 1821.5. So if you find the difference between these two, that will be our bandwidth, because for these frequency range from 1821 to 1784, the return loss is less than minus 10 dB, as you can see. So this is our bandwidth, which is around 37 or 38 megahertz, which is a good value. And similarly for VSWR, for the same values the VSWR will be less than 2. For 1700 something to this 1800 something, the VSWR will be less than 2. Here we go. For these values we have the VSWR less than 2. From 1780 to 1825, the VSWR is less than 2. So this can also be calculated as our bandwidth. For these values the VSWR is less than 2. And to find out the gain, we are going to click on far fields, and the far field at 1800 megahertz. So this is our directivity, which is 6.56 dBi. So that's all for today. If you like my video, please subscribe to my channel Technically Explained.